Okay, I'd just like to go through question 5 in the mechanics part of the half-term paper I gave you. So this is the Maths Made Easy paper. I think this is a really tricky question, but I think it's also really worth covering because it combines the normal distribution with conditional probability. So to start with, it's a fairly standard normal distribution question. We've got the lifetime of a pump, a single pump, having a mean of this and a variance of this. So I've set that up. Remember, this is the variance, which is the standard deviation squared. So when I enter that on my calculator, the standard deviation is the square root of this. We're asked what's the probability that the lifetime is less than 1400. So I set it up like that. Mean is 1500. Standard deviation, I just did square root of 1500. Lower 0. Upper 1400, tiny probability, so that's 0.0049116. That's the answer to that first part. We're then asked about this situation here. We're told that after 1400 hours, everything's still working. These new pumps have been installed at the same time. After 1400 hours, everything's still working. And we're asked what's the probability that the pumping station will fail before we get to 1500 hours. Now, for it to fail, any one of the pumps needs to fail. But it's really complicated because it could be 1 could fail, 2 could fail, 3 could fail, 4 could fail, they all could fail. There's a lot going on there. So I think the answer to part B, it's much easier to work out 1 minus the probability that they're all still working after 1500 hours. Much easier to work this out. So what's the probability that they're all still working? So I'm going to talk about one pump, okay? Just one pump. The probability that one pump is working beyond 1500 hours, given that it had already lasted beyond 1400 hours, that's the probability that this one pump lasts as long as I want it to. I'm only interested in 1500 hours. So this is conditional probability, and if you haven't watched my other 2 videos on conditional probability recently, please do. Okay? Because this is a probability of A given B situation, where this is our denominator, this is our numerator. So this is our denominator. What's the probability that one pump lasts beyond 1400 hours? Well, I've just worked out the probability that it doesn't last. So the probability that it does last is 1 minus that answer. So I'm going to come out of my statistics mode onto my calculator and do 1 minus that. That's my denominator, 0.9950884. That's the denominator. So the numerator is, and that's this probability here. Of that probability, what's the probability, what part of it is it working beyond 1500 hours? What's that? Probability that it works beyond 1500 hours? Don't need to work it out. 1500 is the mean, so I know that's a half. So for one pump, the probability that it keeps going beyond 1500 hours, given that it already had lasted 1400 hours, is that. Denominator, numerator. Now that's for one pump. So what about 5 pumps? Well, if I want them all to be working, that's the first one still working, the second one still working, the third one still working, the fourth one still working, the fifth one still working, that is the probability of one thing multiplied by another, multiplied by another. So it's that to the power of 5. So my final answer is 1 minus this to the power of 5. This to the power of 5 is the probability that they are all still working at 1500 hours, given that they'd all lasted 1400 hours. 1 minus that is the probability that they are not all still working. It might be 1, it might be 2, it might be 3, it might be 4 have failed, but that gives us the answer to that question. In case you're wondering what the bizarre music in the background is, I'm doing this in the maths office, so I can, goodness knows what's going on down in the music rooms, but there you go, sounds like having a good time. I'm not going to do part C, but just to remind you that with hypothesis testing with the normal, we're dealing with a sample, and the distribution of sample means is never as spread out as the distribution of the whole population. So in this case, 5 pumps, so I need to divide my variance by 5. So the standard deviation is the square root of all of that. So when I come to use my calculator in that question, I need to make sure that I am 1500 is still the mean, but that is going to be the square root of, and I think you need brackets here, the square root of 1500 divided by 5. There we go. So that's the values. Lower and upper will be different, but that's how you type in that for that part C. Hopefully you can check your answers in the mark scheme.